We've seen in the previous video that we can conclude that x squared plus y squared is equal to r squared, and we have that x is restricted in between negative r and plus r. In this case, this is our r and minus r and plus r there. So this is my domain from minus r to r, and my range is exactly the same. It is from minus r to r. It is important that we remember both the two notations where x is in between minus r and plus r, as well as the square brackets of the domain, and as well for y. If we look at the standard equation of the circle x squared plus y squared equal to r squared, then we will have the center, the origin, and if I then want to know whether a point lies on the circle, then it must satisfy that equation. Point AB, in this case, that dot there. So if I read from the graph, then my AB is equal to x2 and y0. So is 2, 0 on the circle x squared plus y squared, in this case equal to 2 squared, which is 4. Is that point lying on the circle itself? So if it's on the circle, then it will satisfy this equation here. So if I plug in the 2, 0 on the left hand side, then I get 2 squared plus 0 squared, that is equal to 4, and that is equal to my radius square. So it satisfies the equation, it satisfies that equation 1. That means that it lies on the circle. If I look at any point outside the circle, like for instance here, if I read it off, then my AB here is equal to negative 2 plus 2. If I want to know whether that's on the circle, so if I look at x squared plus y squared equal to 4, then minus 2 squared plus 2 squared is equal to 4 plus 4, which is equal to 8. That is more than 4. That means it's outside the circle. You also have the graphics here, but we can do this independently of the graphics, but I want to show you both the graphics and the algebra. So in this case, if I look at the point AB, I see that the point AB is the point 1, 1. So if I put 1 squared plus 1 squared, I will get 2. That is less than 4, so that's why it's inside the circle. It's inside the circle. It's not really difficult to figure this out on your own, but just remember that we have the three situations. It's either on the circle, outside the circle, or inside the circle. In this exercise, I'm considering a circle x squared plus y squared equal to 9, and I want to know whether point A, B, C, and D, whether they are on the circle, outside the circle, or inside the circle. So first of all, let us do the left hand side. So I will do 1 square plus 2 square. That will give me 1 plus 4, which is equal to 5. That is less than 9, so it means it's inside the circle. If I take point B, then I get 3 squared plus 4 squared, that is 9, plus 16, that is 25. That is larger than 9, so it is outside the circle. And we don't have the picture here, but it's easy to get it from the equations there. If I now take the point minus 3 square plus 3 square, I get 9 plus 9, which is 18. That is larger than 9, so it's outside the circle. And lastly, if I get the point 3, 0, then I will have, there should be a comma there, I will have 3 square plus 0 square, that is equal to 9. That is equal to the 9 of the circle. This is the same thing, so therefore it is on the circle, For the shifted circles here, our standard equation is x minus h squared plus y minus k squared equal to r squared, and hk is the center or the midpoint of the shifted circle with radius r. So now we don't have it in that nice standard form, so we have to rewrite it in its standard form. That means we need completion of the squares. We've dealt with this in another theme, but we're going to apply it again here. We're going to complete the square for that and for that. And because we have an equation, we can just add both sides. So to complete the square, I need x squared minus 4x. I need to add half of the middle term squared, and then I can either subtract it again on the left hand side, or I can just add it on the right hand side. I'm not interested in the value now, I'm interested in the procedure. And then plus the y squared minus 6y, I'm going to add minus 6 divided by 2 squared plus minus 6 divided by 2 squared, and then I'm going to do simplification. Why am I adding that? Remember, we're getting it from a plus b square will give me a square plus 2ab plus b square. So in this center here, I always have double what I had, and that's why I'm dividing by 2 each time. So I can now rewrite this as x minus 2 squared plus y minus 3 square, and I will always use the sign here. I will always use that sign minus and the minus there, because this becomes a plus. And that will give me 87 plus 4 plus 9. So if I add all of that, I'll get 91 plus 9, which is 100. So I get x minus 2 square plus y minus 3 square is equal to 100, which is equal to 10 square. So there is my circle. So this is a circle with center. My HK is 2, 3, and my radius is equal to 10. So if I draw this circle, then I can go to the point x equal to 2, y equal to 3, and I have to have a radius of 10, so it will be something like this. This is 3 and another 2, it will go through that point there, whatever. Remember, sane people are not able to draw perfect circle by hand. We already said previously that our center will be 2, 3 and our radius will be 10. In this exercise, we want to determine whether these equations represent circles. So to do that, we need to write it in standard form. So for my first equation, I can take that part and complete the square, and I can take that part and complete the square. But what I should notice is that when I look at this coefficient here, that is different to this coefficient here, which is 1. So therefore, I cannot have x minus h squared plus y minus k squared equal to r squared because of the 2 there. Cannot have that. The coefficients must be the same. Coefficients of x squared and y squared unequal. So we do not have a circle. If I look at the next one, then I can write it as x minus 0 squared for the x part plus y minus 3 squared, but then I added 9, so I must also add it on the other side. And you can go the slower way. In other words, we've skipped a step here where we said x squared plus y squared minus 6y plus minus 6 over 2 squared is equal to 72 plus minus 6 over 2 squared. We've skipped that step. And if you're confident that you won't make a mistake, you can do that like that. So then, in other words, on my right hand side, I now have x minus 0 squared plus y minus 3 squared is equal to 81. Now 81 is 9 squared, so have a circle with center h, k to 0, 3 and r is equal to 9. So this is most definitely a circle with the center 0, 3 and radius r. Let us look at the last part. If I complete the square for that part, I get x squared minus 4x plus minus 4 over 2 square plus y squared is equal to negative 9 plus minus 4 over 2 square. I've just added this term on both sides, so I will have here x minus 2 square plus y minus 0 square, but on the right hand side I get minus 9 plus 4, and that is equal to negative 5, and that is less than 0, so it's most definitely not a circle because the radius should always be positive. And we could have done the minus 9 here and take that over, but if I have the same situation, suppose I have x squared minus 8x plus y squared plus 9 equal to 0, and I take the minus 9 there, then I cannot say the same thing, because if I now have minus 8 divided by 2 squared plus y squared equal to minus 9, then I must add minus 8 over 2 squared. So in this case I will have x minus 4 squared plus y minus 0 squared, and now I will get 4 squared minus 9, so that will give me 16 minus 9, which is 7. So I will have a radius. So we cannot, before we've not done the completion of the square, I cannot conclude whether it's a circle or not. I must first do the completion and then decide what happens on the right hand side.